Hello students, so welcome to assignment 1.2. I'm going to walk through this with those of you who needs the extra explanation. If you have not been successful the first time round, let's follow along and hopefully you can learn from the mistakes. So in the first question, we are given the variable x and y. They're connected by the equation y equals to 2x plus 4. And we are supposed to calculate the value of P and Q. So what we can do is, this is the equation. All we need to do is understand how the table works. This means that when x is negative 3, y is equal to P. So to find the value of P, all I need to do is substitute the x and y value into the equation accordingly. So P will happen when my x value is negative 3. So when I do this, the result is going to be negative 2. So I know my P is going to be negative 2. And then do the same thing for Q. Q happens when the x value is 2. So that will result in 4 plus 4, which is equals to 8. Okay, right? So let's take a look. So I'm going to plot the points. Let me change the color of my pen. Maybe red for visibility, right? So the first point is negative 3 and negative 2. That will be this point over here. Then we have 0, 4 right over here. And then we have 2 and 8, which will be right here at the edge. Okay, so when we join them together, oops, undo. Let's have a straight line. And since I use the red in this case, let's keep to the color scheme. Right, and there we go. Okay, let me adjust that slightly. Okay, so this will be my first graph, which is y equals to 2x plus 4, right? Now, going on to the next one. Okay, we have a situation where we have y, draw the line, y equals to negative 3x plus 1. So how do we do that? Let me change the color. Let's say green. Okay. Similarly, if I have a y equals to negative 3x plus 1, if I will quickly work out the table form, x and y, right? When x is negative 2, we will find that y is 7. When x is 1, which is the other end, we will find that it is negative 2. So I'm going to plot these points. Negative 2, 7. Negative 2, 7 is over here. As well as 1, negative 2 is right over here. And then I join them together. Let's do that. Oops. I meant for it to be a green line. Put it together, like so. Okay. There we go. Okay. Hence, to solve this pair of simultaneous equation, we look at the intersection point. What do we get? This is negative 0.6, right? Maybe you can put a dotted line, maybe blue, right? You can see right here is negative 0.6, and the y value is let's try again. The y value is somewhere here. It will be 2.8, right? So therefore, oops, change back to a pen, maybe a blue pen now. Okay, so therefore the solution, x equals to negative 0.6, y is equals to, check again, 2.8. Okay, so that's the first question. Okay, let's continue with the next question. So in this question, the variables x and y are connected by the equation 4x minus 5y equals to 9. So again, there's a table provided. We are supposed to find the unknown. What we can do, of course, is just to substitute in accordingly. So in this case, we just need to work out what happened when x is negative 2. When x is negative 2, this equation becomes negative 8 minus 5y equals to 9. So 5y is equals to negative 17. Okay, so y will be negative 3 and where's my calculator? 3.4, right? So then that means a is equals to negative 3.4. Okay, then of course we do that again when x is 0. When x is 0, negative 5y is equals to 9. Y will be negative 1.8, right? So b is negative 1.8. So from here we can plot the graphs. So let me change the color of my pen so that you can see clearly. Maybe red, good contrast with blue. So we have negative 2 and negative 3.4, negative 2, negative 3.4. Oops, let me increase the number of notches here, right? It's negative 3, negative 4. So negative 2, negative 3.4 will be over here. And then we have 0 and negative 1.8. 0, negative 1.8 will be here, as well as 2 and negative 2. So 2 and negative, oops, sorry, negative 0.2. 2 and negative 0.2 will be over here. So again, just take a ruler, draw a straight line. There's solid line, red to match things up. And let's draw this, right? There we have. Okay, oops, let's draw a line here. Okay, so that's our line. Label it, of course. So this will be let's label it here, 4x minus 5y equals to 9, right? Now on the same axis, now we want to draw the graph x plus y plus x equals to 0, right? So let's choose a different color to differentiate this. This means y equals to negative x. Okay, this is an easy graph to draw. So we're going to just connect 2 points, right? Green, let's see, over here it will be, let's mark out this point over here, mark out this point over here, and just join together, line, green this time around, join together. Okay, there we go. Okay, so when we do this, we can see quite clearly that the intersection point is at 1, negative 1, right? So from here, let's change the color for clarity. Okay, hence solve this simultaneous equation. So the solution, x is equals to 1, y is equals to negative 1. Okay, so got that. Let's move on to the next one. So the variable x and y are connected by the equation 2y minus x equals to 2. So again, we need to find the unknown p in this case. So that happens when x is equals to 2. So when x is equals to 2, we have 2y minus 2 equals to 2. That will result in y being equals to 2, right? So p is equals to 2. Okay, so with this, we can plot our graph. Let's go. Let's see, p is 2. We have negative 2, 0. So negative 2, 0 is here. Let's mark it out. And then we have 0, 1. 0, 1 is over here. Let's mark it out. And then we have 2 and 2. So 2 and 2 is over here. Let's mark it out. Okay, same thing. Let's do the line. No purple line. Draw a black line then. Okay, sure, why not? Right? Okay, join together. Something like this. Right? And then that's the first part done. Label it, of course. So this will be 2, oops, undo this, change it to pen. 2y minus x equals to 2. So the next one, let's say on the same axis, draw the graph 4y minus 2x equals to 4. So what happened is in this particular case, if you look at it carefully, let's choose a different color, right? This is actually 2y minus x equals to 2, and it's actually the same line, right? So down here, okay, you can say that they are infinite solutions because they are identical lines. Okay, now move on to the next one. Next one, the variable x and y are connected by the equation y equals to 3 minus 5x. So some of the values are there. Once again, we want to find the unknown. In this case, the unknown is p. So all we need to do is substitute x equals to 1 into it. So y equals to 3 minus 5 times 1. So y is equals to negative 2. That means p is negative 2. This is good, right? Okay. So using a scale, okay, we've done this. Let's draw this. -1 and 8. So -1 and 8. Oh, I need 5, 6, 7, 8. Well, the scale is a bit off. Can I move the whole thing down? It's fine, right? It's fine. 8 is over here. Okay, it's over here. Then let me just see if I can extend this. Let's erase this. Select my line, make it longer all the way up here. Yep. Blue. So this will be 6, 7, and of course that one is 8, right? Okay, let's go back. Then we have 0, 3. 0, 3 is over here, right? And then we have 1, -2. 1, -2 is over here. Okay, let's join them together. The line, red this time round. Okay, and it should line up perfectly. There we go. Oops, a bit off. But it works, alright. Okay, so after this, label this. So it is a y equals to, change the pen, y equals to 3 minus 5x. There we go. Okay. Now, in the second part, they say on the same axis, draw the line 5x plus y minus 1. So what happened is if we were to take this and rearrange it, what do we get? We get y is equals to 1 minus 5x. So when we compare these two, what we realize that this time round the y-intercept is at 1 instead of 3. So we want to draw this accordingly. Let's not use blue because blue is already there. Okay, I know that it will hit this line over here, right? And it's actually 2 units lower, so it's actually over here. And 2 units lower is over here. So if I will join together, it will look like this. Let's change the line color, right? Zoom in a bit. Okay, it will look like this. There we go. Okay, so what's the situation? The situation is, okay, there is actually no real solutions because the lines are parallel, right? Okay, so I hope you have some success with this assignment. If not, do your corrections and all the best, right? We should stop.